I want to talk about mitochondrial transference. So just a quick reminder, mitochondria.
Well, mitochondria are the powerhouses within each of our cells. So they're the energy production components within cells. But we inherit our mitochondrial information or our mitochondrial RNA from our mum. So a lot of our transference of diseases, of our mitochondrial patterning, of all of that information around mitochondrial triggers around diseases comes from our mother. And so it's really important to be looking at, if we don't have healthy mitochondria as a mother, then that predisposes our children to certain challenges, but also that the mitochondria from the father. And we spoke about that in that last podcast that we did, the idea of both parents giving mitochondria with either their sperm or their oocyte, and then that determining the health of the child and the mitochondrial transference of that information. But particularly with mums, if the mums have any damage in their mitochondria, it significantly affects the brain development of our children and then their emotional well-being from then on as well. It's quite.
So what's the connection between a healthy mitochondria and protection against negative DNA mutations? Like, how does that happen?
So it's because of the information and that generational information that goes from the oocyte, let's say, and whether or not there's enough mitochondrial health within the oocyte to be able to then lay down those initial cells in the embryo. And then all the neurological development goes with or without that deficiency, depending on if it's been addressed or it hasn't. And then we know that, the older the mum gets, the more mitochondrial damage she can have, which is why we're more predisposed to having chromosomal abnormalities or psychological disorders in our children. And that's definitively one of the main pathways that we want to be addressing so that we can protect the next generation that way. But it's a way that we can, like if you think about any of the neurological developmental aspects of kids, it's one piece in that equation. So if we think about the actual brain development of the baby correlates with our brain capacity when we're pregnant, our neurological outputs, our hormonal outputs determine that pathway. And then we look at the internal cellular structures, that mitochondrial information, then the dovetailing of both of them and the combination of both of them then determines and predisposes us to various pathways. So it's quite important to be thinking about it from DNA mutations, from chromosomal issues, from DNA information, and then you're starting to get into all the science around, genetic disorders and genetic predispositions. But what switches those genes on is the health of the mitochondria, and what is selected and what is used is determined by the mitochondria.
Mm. And also probably ties into just being healthy and vitality and all those sorts of things as well. So
yeah, absolutely.
And so how can people ensure that their mitochondria are healthy? What are some practical tips?
Mitochondrial health are number one, sleep. And having enough sleep, and all of that new research that's coming out around sleep and the timing of needing to go to sleep at a consistent time each night, and making sure that you're getting those 8-9 hours a night before, how we've always talked about it, the 2 hours before midnight are the most important. So going to bed as early as you can, making sure that you're exercising on a regular basis to have all the various muscle cell fibers be activated to assist in the regeneration of mitochondria, making sure that your diet's really clean, staying away from environmental pollutants that will negatively affect mitochondrial health. What am I forgetting? Emotional health to an extent, definitely as well. But there's lots of interesting supplements, and that's sort of where, we're getting a lot of information, certainly around ubiquinol is probably one of the biggest ones. All of the anti-aging pathway precursors, the NAD pathways and things like that will help to assist mitochondrial health. But then all that methylation information comes back as well. So if that methylation process isn't working, then mitochondrial damage is much more pronounced.